una sesión bastante interesante y además en inglés. ¿Por qué? Porque, bueno, generalmente en Codetitlan siempre estamos presentando todo en español porque nuestro target es precisamente poder compartir información con nuestra comunidad de Iberoamérica para poder platicar con la gente y que puedan saber cuáles son las tendencias en tecnología que están ocurriendo en el mundo. Y pues el día de hoy tenemos una invitada muy especial eh, y el capítulo va a ser en inglés, pero van a tener aquí subtítulos para las personas que estén interesados en verlo y vamos a aprender de una herramienta nueva, algo bastante loco que, bueno, implica de el uso de neuronas vivas para poder trabajar en tecnología, creando microprocesadores, que bueno, si eso, algo que estábamos platicando de ello es si utilizamos neuronas vivas para trabajar con inteligencia artificial, ¿realmente esto va a implicar ahora que no sean transmisores de computadora o cómo va a ser, no? Pero bueno, voy a cambiar de idioma o si quieres explicar tus...
Vamos a hacer, vamos a hablar de cerebros reales haciendo trabajo que tradicionalmente hacen las computadoras. ¿Qué les parece? So, yeah, we're gonna switch to English now, so that we can have. So, it should be transparent for everyone. Just read the subtitles. It'll be fine. Hey,
Okay.
welcome, Evelina. Thank you very much for joining our podcast today. We were saying to the rest of the audience that it's super interesting to have the topic like this. So please tell us a little bit about you. Welcome.
So I'm happy to be here. I'm Evelina Curtis. I'm a neuroscientist by background, and I'm currently working on the future of artificial intelligence, what we believe will be the future, and on biocomputers. So this is a project which combines neuroscience and engineering. So it's actually a dream of engineers, of many engineers, to build a thinking machine. So also Final Spark was founded in 2014 with the dream of building a thinking machine. And after a few years of research, the team realized that digital artificial intelligence is too expensive because to make it smarter, you just need more energy. And we actually see this today with the great success of ChatGPT, that it's in the big part due to the huge funding for the energy. And this is why Final Spark decided to switch to biology because to make a big revolution in artificial intelligence with a small budget, you need to be very innovative. You need to have some idea which will be different than what other people are doing. And decided to switch neurons. I think neurons 1,000,000 times more energy efficient than there's cheaper to work with them. And it will be much cheaper to run artificial intelligence algorithm on living neurons than on digital.
That's amazing. So, okay, hold on. That's a bunch of things to take in. Let me break this down a little bit, piece by piece, all right? What I understand is that you're building technology in a company called, what is the name? Spark?
Final Spark.
Okay. You guys are building technology and you reach a point where you say like, we need more processing power and that processing power is extremely expensive. We need to developing a technology that will use something that is more efficient. And you found out that living neurons could be one alternative, and that's what you are investing on right now, your efforts and
Yes.
you're betting on this, all right?
Yes.
Wow,
So
that's incredible. So it's basically, yeah, in a way, we work with kind of like just food, right? And running a server farm these days for a simple LLM model will take a bunch of energy from different sources. I see governments and a bunch of companies investing big money in new energy sources because they are realizing that we're going to need it soon. And you guys are going to the other side. So let's make it cheaper instead of making more power by using something that has been proved for aeons that works as a processor. Is that correct? Tell me a little bit about that.
Yes, actually, we can believe that neurons are good in processing information by looking at our brains. The fact that we can talk today, it means because our neurons are processing information. However, in the in vitro, in laboratory, it still has to be built. So at the moment, we are very early stage. So we managed to store 1 bit of information. So it's really early, but we are working on this. We are working on the possibility to program neurons and to use them as a processor.
All right. So I guess it's kind of like a system, right? You put an input, expect an output, and you are kind of need to make that somehow predictable. If we compare that, if we compare it against a regular processor, like processors are built with millions of instructions, and programmers can use those instructions. Are we assuming that those instructions or a different set found in our neurons, and we can kind of take some control over them?
Well, that's the objective, to have control over neurons, what is very difficult because neurons, in contrary to computers, are a dynamic system. Computer is stable system, and neurons are changing over time. So the behavior of neurons is changing. So it makes the whole story more difficult. But yes, we want to achieve a meaningful relationship between input, so the signal which we send to neurons, and output, what we measure out from neurons.
That's amazing. All right.
Okay, now, well, Final Spark, it's not your first, let's say, application that tries to do this, right? You've been, I mean, you are a scientist, and before that, you studied psychology, and now you're working in neuroscience with different engineers. That you got involved in suddenly checking how human behavior is, and then you think of neurons and how to mix them with artificial intelligence.
I did neuroscience because I was always fascinated with brain. I did research on brain imaging. And after that, I was curious also what is outside academia, what is in the real world. So I left academic research and I started to work with startups. And in this way, I discovered artificial intelligence because it was widely discussed in many projects. So I became fascinated with that. And I started to see the opportunities, how great they are. And I started to work on commercial applications of artificial intelligence. And I was lucky because I was at the time in London, and I met the founders of Final Spark at a conference, which was AI Summit in London. And I was really impressed by the work because they're engineers, and they started from the scratch the project in biology. So it's very impressive because I know how difficult it is to learn everything, in the new field. And yes, and this is how I started to work with them because I had commercial experience with artificial intelligence and scientific background from neuroscience. So it seems to be perfect project for me.
Okay. What do you find super impressive about Final Spark with all the expectations that you had when you decided to switch in this new world and the applications that you could see and the scope of biology and neurobiology with technology? Today that you have Final Spark in your hands, what do you love the most about it?
Well, I think the best are the people because when you work on a very innovative project, usually people who work on that kind of stuff, also in the academia, usually people are great. So I would say that's the best. And also, well, I work on the commercial side, so it involves a lot of talking, which I love to do the most.
Yeah.
And I like the fact that there are so many things to discuss about this project because people ask us all kind of questions. They ask us about technical questions. They ask us about biology. They ask about commercial side. We discuss also investment opportunities. So there are so many angles from which you can look at this project, and it's so multidisciplinary. I always like this kind of multidisciplinary stuff. When you have to combine the knowledge from different fields, because that's more exciting than just sitting in one topic. It just makes your work more it brings you more variety in your work.
Okay. Now, as a user, of course, I have an understanding. I have read about Final Spark and what they're doing, but could you explain to Codetitlan, like, let's say people has never read about it, and this is the first time. What is Final Spark, and specifically, what do you want to do with this tool?
So Final Spark is a startup in Switzerland, and our objective is to build computers from living neurons. And what we do today is we have a culture lab. We have living neurons there, the same as in our head. And these are actually standard methods in biomedical research, so nothing new about this. But the new is application, because we culture neurons because we want to use them as processors. So we basically put neurons on the electrodes so that we can send them electrical signals. We can also measure the response from neurons, and we try to make sense between input and output. And the objective is so that we can run algorithms, so that we can use them as processors. And in the future, we want to build bioprocessors. So bioprocessor will be central big processor with a huge structure, because now we have very tiny little block of living neurons, around 10,000 neurons each and half millimeter diameter. So they are very small for testing. But in the future, we want to build huge structures of neurons, which can be much bigger than a human brain. This will be, of course, all artificial. And we want to basically, we want to provide cheap computational power. So people can connect. Like today, you can connect to the cloud service. In the future, you will be able to connect to the cloud service where there will be bioserver. So also for the end user, for the people who is using AI, we don't want that they feel the difference, because we want to be able to run the same algorithm, the same stuff, but with different, much cheaper server inside. So for the end user, hopefully nothing will change except for the bill.
Okay. I have like so many questions. That's many other, as you mentioned, probably everybody asks about a bunch of questions about this. But first, where do you get these neurons from?
This is a good question. So actually, this is why this project is possible today, because now we have methods that we can just take human skin. Human skin, we can reprogram the cells and get stem cells. And from these stem cells, we can get any cells you want, including neurons. So we can actually very easily get huge quantities of neurons.
Okay. And by, yeah, I don't know, maybe just combining chemistry as life came up, I guess. All right. And another question will be like, mentioned that we like one of the goals is to be able to run the same kind of processes that silicon-based processors run today
Yes.
into one of these large array of neurons that probably individually will be able to do just a few calculations, but
Yes.
group, you are going to be able to solve this kind of problems. But you also mentioned about the non-predictable nature of how neurons work, right? And that's kind of more into the quantum domain of things. So it's not like we're trying to solve a problem that is more on the predictable side of things, like LLMs are more, they are based on just statistic results.
Yes.
Instead of going directly to aim to, okay, make something that is by nature statistically based into something deterministic. What's your take on that?
I think that the neurons are still able, it's possible to somehow have controlled neurons. We can have systematic thoughts. So that means in some way, it's possible to control neurons despite the fact they are dynamic system. It's just that we need to discover that. And that's actually the difficulty, because if we use different substrate than digital, then we have to figure out everything from the scratch again. So how to program them, how to approach, how to build the framework for actually how to think about the system. We have to build everything from the scratch. But we believe it's possible because it's already proven in nature.
Of course, yeah, makes sense. And yeah, I have way too many questions about the specific use case, but to move more into something like, if I am a developer and I would like to get involved into something like this, what do I have to learn, or where do I have to aim my career?
So at the moment, as was similar with the digital hardware, at this early stage of the development, you really need to know the hardware very well, because we don't have high-level programming for neurons. Everything is very low level, so it's like you would use Verilog for digital. And you have to really understand a little bit about biology, how neurons work, how they are spiking, what does it mean, what is the level of spike, so that you can also distinguish between real signal and the noise, because noise actually is very important. In the biological system, there is always a lot of noise. So I think what is really necessary is to understand a bit of biology. And then, of course, Python, okay, then for developer is very easy. And then that's these two things need to be combined. So some skills in Python, in program understanding of biology, so that you know what you are doing. Because when you send signals to neurons, when you collect the data, you just have to know a little bit about the biology, so that you, for example, don't put too much current in your neurons, because then you can kill them.
Okay, great. Hey, and more into that same line. So in the Ibero-American region, often these kinds of projects are managed by big laboratories or not usually big companies. And I want to say that I haven't heard of anything similar to that anywhere in the region. Do you have any, what's your, in terms of distribution, how do you see the access to this technology for the whole of humanity? Is it something that is going to be very exclusive at first, or is it something that can be used by, I don't know, can be developed everywhere?
Well, actually, our technology is available for anyone, to anyone in the world, because our lab is available remotely. So we have actually researchers from universities from all over the world who are using our lab, and they can run experiments the same as our scientist, which is sitting in Switzerland. And we also have even third commercial clients. So we have people who pay us to get access to our lab, and they are from different regions in the world. So that's not really a barrier. And, maybe it's good to mention, because you said usually it's this kind of projects, maybe scientific projects are done in the laboratories. But I think that this project, this approach of using living neurons is maybe a little bit too disruptive, because still in science, you make little steps so that you can publish. Because if your idea is too crazy, maybe for too long time, you won't be able to publish anything. And that is at risk. So actually, I think in research, usually we do little steps so that the ideas we have are more sure to work out, so that we can publish them. So there is a lot of pressure in academia for publication. So this approach for using living neurons for computation is actually completely crazy. And maybe this is why startups are working on this, not academics so much. Academics are collaborating with us, but they haven't built the system so much. So we have actually two competitors to our knowledge. One is Conico in US, and another is Cortical Labs in Australia. And they are also startups.
Okay, that's something to consider, I think. I guess that's why you also think that this is the right moment to come out with this solution and start experimenting with this, right? So
Yes,
Those-
well, moment is right, because the technology is ready for this kind of things, for prototyping. Because as I mentioned, we can produce big numbers of neurons easily. It was not possible 20 years ago. Also, there is some progress in hardware, so that we have electrodes, everything what we can interface with neurons. And also the progress of artificial intelligence is helping us. And also, I would say maybe the possibility to have huge servers, because we have a lot of internal servers in our laboratory, so we can collect huge number of data. That's also helpful. So let's say technology is mature enough so that we can start to experimenting within living neurons.
Well,
Okay, I have a question. Final Spark was kind of founded, right, in 2014. Is that correct? Okay. Something that we have been talking in Codetitlan in the last episodes that we have is that technology has been changing so much. So, I mean, it always changes, right? But yes, like the last couple of years, it's been crazy. Talking about the last months, I mean, you're understanding something and you believe that, that's it, that's how it's gonna be, and then the next week you have something new that it's completely different to what you thought you already kind of understood. In terms of technology, well, the knowledge that you have in Final Spark in 2014 for today, if you kind of check the time, what would you say has been more challenging for you guys? Because with artificial intelligence and it opened up a lot of knowledge too in medicine and biology that we didn't knew a lot, I don't know, like 5 years ago, right? What has changed for you guys, like in the years that you kind of had to review if you were in the right path?
Well, actually, there is not so much literature about what we are doing because it's so new. So if you try to research about learning in vitro, about trying to program neurons, it's almost nothing in the literature. So that's a bit challenging, I would say. And yes, we know much more about neurons, about maybe how we can cure disease, how a brain is working. But still, for the programming of neurons, it's still a big challenge, and there is not so much literature. And actually, we still have to experiment a lot.
Okay.
can I reformulate that question from Carlos? And I think this, since you didn't start like a couple years ago. You've been around for more than, I guess, is it 7 years or so? You have experienced the transformation of the whole environment in the world, right? So we have a way different situation today as what we had 5 years ago and 3 years ago. I guess Carlos' question was how, as a startup, you have experienced all these changes in the environment. It's been challenging for your research, or how? Yeah.
No, actually, we are quite stable team. We are a very small team because we have limited resources, but I would say we are stable and the work is progressing slowly, but in stable way, to be honest. So I would say we are not so much, I wouldn't say that it's changing a lot because of the things. Okay, technologies change. So maybe we sometimes get some cells to test or some stuff. People come to us with ideas because since we become a little bit popular because we do podcasts, there is a lot of press articles about us. So what has changed is that people are coming to us with a lot of ideas. So that's nice, of course, that we have some interest. But like internally, I wouldn't say, I mean, it's just, well, we for sure apply LLMs, of course, like would be a bad idea not to do this. So of course we are changing, we are adapting to new technologies. But I think there are a lot of things in our work is not changing.
Oh, that's great.
Usually, with the old stuff, you have to reach out to the people when you do business development. It's nothing changed. It's always the same stuff that you have to search for the right connections. And in research, also, is you just have to experiment and
That's great. Hey, feed my inner geek a little bit and tell me about, in terms of like numbers and the technology, that you have a big promise of saving energy.
yes.
Please tell me more about that. I'm very curious about.
Well, so we know that brain process information in totally different way than digital computers. I actually wrote a blog article about this recently. It's on my LinkedIn profile. So there are a lot of differences between digital and brain. So for example, brain is encoding information in time and space. So it matters where exactly in our head and at what time the neurons are active. This is an information. Also in the brain, processing information and memory storage is in the same place, in contrary to the digital computers, because usually memory and processor is separate. So that also saves energy. There are also a lot of much more connections. There are a lot of recurrent connections, which are possible in digital, but a little bit difficult. But in brain, it's normal. And it's a lot of them. So in general, the connection, there are much more connection between the neurons in the living neurons. So there are a lot of differences. Also, how we approach incoming information, because, for example, our brain is filtering information. So we don't treat every information the same with the same importance, while for computer it's actually the same importance. So there are a lot of differences, and some of them explain why brain is so energy efficient, because it's making a lot of stuff in much more efficient way.
And we're talking, what, 10x, 100x?
Half million.
It's more
Yes.
efficient than energy.
Yes, yes, incredible. But they are independent researchers from our team who, independent from us, people who that neurons are 1 million times more energy efficient than digital computers.
Right. That's amazing. In my head, and I'm not sure if it's not, but this poses even philosophical questions about what actually thinking is, and
Yes.
how actually thinking works, right? Because if we could just put an array of all our brains together organized and we call it, like, I don't know, society, why is it not optimal, right? And if our and that what you're saying is that if you put the same basic components in an organized way, you can basically get predictive results in a very massive way. Is that correct? Like, why cannot we do that with our current neuronal setup, and we need to create a new neuronal organization?
With our brains?
Yeah, that's we as a collective of humans,
Yes, but it's a bit different because we have to communicate using language, and we cannot really see each other's thoughts. But if we have living neurons, we assume that we can build structure of even 100 meters, which will be all neurons. So it's kind of like one processor. So it might that work differently.
Massively distributed, but
Yes.
small operations that are controllable.
Yes, and that's the totally different thing, because actually, we don't try to reproduce the brain. because brain is very complex. Of course, it has a lot of little structures which are impossible to reproduce, but we only the same building blocks, which are living neurons.
All right. And more philosophy things that come to my mind is like, if it's organical process or is it still artificial intelligence?
Yes, it's a good question. Let's see later. We get a lot question also about consciousness, about what border human and machine. But actually, this question is valid with many other technologies, because also with our smartphone, we can assume it's a kind of extension of us a little bit. There are philosophers who say that. So I would say, but yeah, there are also questions specific to. But I don't think maybe they are specific, because about consciousness, you could also talk about digital computers. There are scientists who also question if robots in the future, when they become very intelligent, if they will be also conscious. So actually, we get a lot of questions also of this kind, and we are of course not competent to answer them, because we are scientists and engineers, very pragmatic people, very from technical stuff. But this is why we reach out to philosophers. And we encourage philosophers to also work on biocomputing to help us to answer all these questions.
Yeah, that's something we can think about here in have those labs, so we can start thinking about how to look that. And in the same line, what are like your biggest challenge in terms of regulations and so that you are facing? Because obviously this has to have some ethical implications that you need to go through, right?
So for now, there is no specific regulations for biocomputing, because it's very early stage. But we are absolutely aware of that something can come up. And this is actually why we talk with philosophers, because we hope they help us to also maybe develop some recommendations if this will be needed. So we want to be prepared, and we want to do our best that our work will be accepted by society. So if there is anything we have to do from the philosophical, ethical point of view, then we will do this.
All right, but so at the moment there's still nothing on the horizon about.
No, because it's too early stage. Because at the moment we just have little block of cells. We try to send them signals, and we analyze the answer. But this is very, very early stage. So there's a rather fundamental research on by neurons.
Sounds good. Another question, and why human neurons? Couldn't other species of neurons be more stable than human?
Well, actually, we assume, based on what we see in nature, that humans are the best. However, at this stage, it doesn't matter. We could also use rat or mice, probably. But because the method that we can get them from human skin is easy process, so that's why human neurons are the best, also the easiest.
Okay, you are pointing to the biggest machine from the start.
Yeah, I mean, in the future, it maybe matters because our neurons are a bit maybe different structure than rat or mice neurons, for example. So if we have advanced algorithm, it maybe matters. But at this stage, when we do very basic research, I don't think it would matter which kind of neurons we have.
Okay. Carla, please go ahead.
Yeah. So today in your website, you have like access for different levels, right? You have an access for people who wants to use your application and start playing a little bit with these neurons. And then you have an access developers. Actually, I see that you have a GitHub documentation there. And also I see that there's a space for universities. If someone from America or any other country wants to join, how can they join and what can they play with?
So universities can apply for free access, but it's very competitive. Of course, we are very strict to choose the projects. It has to be something we haven't tried before, and something which we believe has a big chance for publication. So that's for universities. And then for private companies, individuals, we offer paid access, which costs shared access. So that means you share the same neurons with other people. That's $1,000 per month. And if you want to have the neurons only for you, then you pay $5,000 per month. And what you can do, so you get the access to the laboratory remotely. So basically, you open internet browser, and by writing Python code in programming language Python, you can design the experiment. You can decide what will happen at which point. You, for example, set some signals, electrical signals to the neurons. You have some idea how to stimulate them. You test this. And then you measure the response from neurons. So you measure which kind of signals are produced by neurons. You can analyze this. And some people have some crazy ideas. So for example, we had some user who tried to combine our neurons with Twitter posts, I think. And he tried some algorithm so that Twitter post will change depending on the signal from the neurons. Although at this stage, it's still often random what comes out from neurons. But of course, you can do such a kind of things. So yeah, it's good for technical people actually at this stage. So you have to have some ideas on how you would play with neurons so that you get some outcome. So for the moment, it's not for analyzing. We cannot offer computational power. So our neurons cannot analyze images or text. It's more signal processing. So you send some signals to the whole objective, I would say, most often is how to get some relationship between input and output.
But even just a random number, if you can prove that it's truly random, it has a bunch of value to many things, right?
Oh yeah, that's interesting actually. Yes. Because randomness doesn't exist in computers, yes.
Yeah. So yeah, there you have.
Yes, maybe we can have application, yes, to generate what numbers.
I'll have join and play with your neurons to see if we can. And as a researcher, is there any hopes to get access to this kind of technology?
So you have to be affiliated with with university, and you have to prove that you have a big chance to publish. Because actually the whole idea, because for us it's also a cost, of course, if we give access, because we still have to run the lab and it's actually a lot of work. But we decided to give this free access to universities because in case they publish in a peer review journal, the work which was done on final Spark Neuro platform, then it's good for us also. So that's the criteria.
That's good.
Okay, perfect. And what can we expect from final Spark in the?
So actually our timelines are a lot longer because the research is very slow because it's really deep research. So we are currently talking to investors. We are searching for 50 million Swiss francs, which is around $50 million. And we want to accelerate our development because currently we are self-funded by the founders. They have money from a previous startup they did, which was very successful, but it was much more traditional digital technology, which brings profit faster. But biocomputing is very slow. So if we get investor, we can move faster. And then with investor, we plan to solve the next milestone in 2-3 years. And the next milestone is learning in vitro. So how to make neurons learn something in the lab, in the dish. So they can perform some simple algorithms. For example, maybe image recognition or stuff like that. So that's the next milestone. Another milestone after that will be advanced algorithms. So we would like to match the performance of digital computers. And the last milestone will be scaling. So we want to make these huge structures of neurons, which will be in big bioserver available remotely. And we plan to achieve this in around 10 years with investors, but we also anticipate that it can be very profitable. So once it works, it will be very powerful technology.
Okay, perfect. Right. It as it is. To me, it's funny, not funny like but like, that our podcast usually goes more into technology trends and how fast that world is moving. And it hours me that science, and when we're talking about biology, it has its moments. You could be in a hurry, but biology has its
Doesn't mean
no.
Yeah. So yes.
Yeah. Faster you go, keep a lot of things that you shouldn't have, right?
Yes, absolutely, you're right.
Okay.
That's pretty neat. And now you mentioned those timelines, and there is another big technology that is trying to solve similar problems, and that's quantum computing. How your technology compares against that, and how does it fit in the puzzle?
So what we have in common is that we are in the field of unconventional computing, so some alternatives to digital, but everything else is different. So quantum computers are meant to be very fast. As far as I know, I'm not an expert, but they will be good in cryptography, in making some stuff. But actually, living neurons are totally different because living neurons are not fast. They don't have great memory, but they are very energy efficient. So for some deep problems, a complex problem, we believe for generative AI, somewhere where the speed is not the most important, but you can process some information with a much lower energy. So we think that actually quantum and biocomputing and even digital computing, it's all complementary. So I generally believe that in the future we will have many different processors. And I think we can see already this trend in engineering because people are working more and more on specific chips which are optimized for specific tasks. And I think that will be the future, that we will have many different chips, digital and also biocomputer, we will have quantum, and all this will be used for different tasks for which they will be the best.
I love that answer. Yeah, I can even imagine. I can even picture that future where you can distribute the loads of your computing loads depending on what's better to process them.
Yes, absolutely. I think so.
Amazing.
But of course, quantum is a bit longer because that's also, we are actually like quantum, but 15 years younger, let's say, because quantum computing field is existing for a bit longer. So they are more advanced also.
Yeah. Yeah, it's very impressive. We had some people coming to the podcast about that, and it's blown our minds as well. As much as this, I think. Carla, do you have more, or I'm gonna geek out with?
Well, I'm just you already talked about what a developer requires to learn if you want to work in this field. But how about people in general who is going to be using as users this technology? I know that we wouldn't need to expect a lot of changes on how start processing, but how are we like the common people, how are we going to enjoy the benefits of this technology?
With lower bill for artificial intelligence. So that's the main difference which we want to make. That will be cheaper.
Okay. And what does
Oh, that means that, already if you want to use ChatGPT, for example, you have to pay for this. And I think we can expect the future will cost more because I believe that the prices currently for LLMs are lower than we should pay to make it profitable. But of course, they want fast adoption. So they want the producers of LLMs want that we get used to use. I believe in the future they can be much more expensive. And also I think in general we can expect that the usage of AI will be more and more if we develop more automation, more different systems where you have also generative AI. I think it will be increasing a lot. So maybe today it seems to be not realistic yet, but I think one day it can become very expensive to use LLM. And yes, and it will be very important that we will have some alternative hardware. You can run much cheaper.
okay?
Absolutely. That also translates into more access for more.
Yes, because I think I mean we already see this actually trend because there was some discussion in press I saw about the availability of GPUs, like which country will get more also raw materials or chips ready, and that will affect also the competitiveness because you have more chips, you can run more AI. So this, and the more I will use, the more scarce it can become, or let's say limited supply. So it will become also more expensive. So I think work on alternatives to make it more cheaper and more to everyone.
Okay, this leads me to another question. So, how environmental friendly it is, because we know there's a big criticism about the amount of water that we spend cooling off the current processor. So, how does it? I know it's in early stages, but what will be your goal?
Well, actually, I don't know the numbers for the water usage in the not say. Well, we need some water, of course, to culture neurons, but I'm not sure it's really huge amounts. I wouldn't say so because neurons are always in the liquid because, of course, it's natural. We are also 70% of water, our bodies. But I'm not sure it's so huge. I don't think so because I know that data centers, they need cooling, but so that doesn't exist in biocomputer. And of course, we use much less energy. We will use much less energy. So yeah, that's the whole point, that we will be much more sustainable.
All right, that's great. So it's also something that you have in.
Yes, of
Don't
course,
worry.
it's because we try to make we actually did some calculations based on what we have today in the lab in terms of prototype. and we try to estimate how much energy we will use, for example. Of course, so our will much cheaper is in this case synonym, because it will use less resources and it will cost less.
Yeah, correct. And also, if it's something biological, you don't actually need like this special resources. Or how they call? I forgot in English, but it's sorry.
Rare metals, for example.
Yeah,
Absolutely. Yes, absolutely. You can produce huge amount of neurons just multiplying them. But what is also great is when you have to throw away them. This is also, I think, easier to, because it's just biological material, so it will. It's not like plastic; it doesn't stay in the soil for a long time.
Yeah, probably you can even develop something that will fit into feeding plants or something like that, and
Possible,
that-
yes.
the
Possible,
rest
yes.
would be great. Huh? You should consider that in your.
So we will have bioserver and a big garden around. Yes,
Yeah, lovely.
Yeah.
that's actually a good idea. Yes, we didn't
Uh-huh.
even want this yet.
Okay, perfect. So, well, Evelyn, from our side, I think we have more questions, but of course, we don't have hours. I mean, I know we do, but in terms of the podcast, we have to start saying goodbye. But what are social media people can click, or the channels where we can see where are you working, and how we find us?
Sure. So finalspark.com is our website. There are a lot of resources. You can also fill in the form on the website, and we come by more resources, and it's always possible to ask us questions, whoever is interested in the project. We also have LinkedIn profile. We publish there quite regularly, and also Discord. Oh, Discord is also important. The link is also on our website. There is big community there, also very technical people. So there are a lot of technical discussions. Also, our users are there, so they exchange some information. So that's also a very good resource.
Okay, this part of the community is free, and anyone can join.
Yes, absolutely. Discord is for free. Everything is free. Yes, and everyone can join.
Cool. All right.
Perfect. Excellent. So, any other questions, Ed?
Yeah, but I don't want to really start dealing into epistemology and things like that. So yeah, no. I think I really want to explore. Sounds very interesting to me, and yes, indeed, one very important thing for me particularly is really want technology to be accessible by more people. You know, it's just only a handful of humans who have access to really advanced technology. And I think this should be a common. If technologies like what you help us reach that goal, I'm super happy to play with them and even support, because yeah, I think it's cool, and also if renewable, I think it's pretty clear that we cannot follow in this same path of consumption and exploiting our resources in this way, and there should be alternatives. And any alternative that is presented today as a way to explore, for me, adds value to the human living better. So yeah. Kudos on that. We'll keep.
Thank you so much. Thank you for the nice discussion. It was a pleasure.
Thank you.
Yep.
And well, Codetitlan, síganos viendo, sigan revisando cada uno de los podcasts que tenemos. La verdad es que la intención es que vayamos aprendiendo más cosas, y la verdad es que el mundo de neurocomputación va a ser algo que no debemos de perderle la vista, porque yo creo que de cierta forma vamos a tener que regresar a los basics en algún punto con todo lo que está pasando. Entonces, síganos viendo en Discord. Seguimos en contacto con Final Spark. Gracias. Thank you so much, Evelina.
Thank you so much.
And thank you, Ed. Nos vemos pronto. See you soon.
Bye bye.